Really a little more complex queries, a little bit. So the movies which are directed by the collaboration of most directors, and in it, in these two queries we have utilized this one more keyword, that is which is collect keyword. So let's run this query and then I will explain you what collect keyword does. So this query would show us the movies which are directed by the collaboration of other directors, and again not just other directors, it is also showing us that the movie which have the most of the directors in collaboration. So the movie name is Cloud Atlas, and which have three directors, and these are the name of directors: Tom, Lana, and Lily. So basically, what this query is doing, up to here, it will show you all of the names of movies which are directed by some person, and if you cut it till here, now what it will show, actually here I should write P, P for person, and count of that persons as directors. So because these persons have directed in that movies. So this movie is going to show you that which movie have the number of directors, and you can see there are these three movies have two directors involved, and this movie have Cloud Atlas have three directors in collaboration, and other have one collaboration. So again, now if I use collect keyword here, collect function here actually, so what it does, collect actually make a list from multiple items. So it will take the names of those persons of that directors. We should use P here. So it will also show you the name of those directors as well. Okay, so let's see. Okay, so now the number of directors and the list of those directors, as you can see that names and directors count. Now it's more semantically improved, and you can also write here movie. So Okay, what we need now, we want to by order by directors count and in descending order. So Cloud Atlas has come on the top, and now we can just filter it by applying the limit clause, limit 1. It will filter the results, and it would give us the name of movie which have the most collaboration of the directors and the name of directors as well. So you can see how we can step by step construct a query to extract some complex information out of the graph. And similarly, I have a little bit more tricky or um, more interesting query. And what is that? The most recent year that has the maximum movies released. Mean that one thing is that you want to see the maximum movies released in a year, and then you are seeing that most recent year, which is the most recent year in the past years that have the maximum number of movies released in that year. So this is a query. Let run this, and then we will see, and we will examine it step by step. So according to this graph, 1999 is a year that have the maximum number of movies released, which is 4. Okay, let's see how examine. Let's examine it step by step. So let's cut it from here, and then let's remove this length as well. Okay, now you should understand that what this query would do. This would match all of the movies node, and it would return its release date, and it would collect the title against. Okay, so let's delete this collect as well to see that what it would show. So now this query should select, first of all, should select all of the movies node, and then it should show the release date of that movie and the title of that movie. Okay, you can see we have release date and we have the title of movie. Okay, so now you can see that movie names are distinct, but the years are repeating. Like in 2003 this movie was released, and in 2003 this movie was also released, and so on. You can see 1998, 1998, and in 1998 these 3 different movies were released. So mean to say that we can collect the unique items in a list by applying collect function. So it would collect all of the movies against a release year. So now you can see in 1999 these 3 movies were released, and in 2003 these 3 movies were released, and these 4 movies were released in this, and these 3 and 2, and so on, so on. Okay, so now basically what we have to see that maximum number of movies. So how we can see, we can just find out the length of this list. We can take decision on the length, we can take decision on the length of that list. Of course that the length of that list would tell us that how many number of movies would be released in a year. Okay, so now we can take decision on this length. So first of all, we have to sort it on the base of length. So let give it a name as L for length, and then we have to sort it out order by, remember to keep your keywords fully capitalized, order by L as descending, DESC. Let's see. Okay, fine. So it has sorted the results based on the number of movies released in them. It has sorted all the results based on the number of movies released in a year. Now, to find out the most recent year, of course, we have to sort the years as well. So order by n dot released as well. So let's see. Okay, so it's n dot, so we have mistake here, n dot released. Okay, fine. So now it has sorted the year as well, along with this number of movies. So now we have the most recent year, that is 1992. um, Sorry, it has not sorted years in descending order, so we should also use keyword here. Okay, now, so now we have the most recent year, that is 1999, that have the most number of movies, that are 4 released in that year according to this graph. So you can see how we can and now if we want to limit it, so we can limit it by 1, so to get exact results. Now done. And once your query is in working state, you can increase its understandability by giving it proper names like this. You should write proper variables name, like you can write, but keep in mind that variable name should be in fully lowercase, like movie is the name of variable, and capital M capital shows that it's a type, and you can write here like movie dot released, and length collect movie dot title. Now you can see that it is making more sense to you, movie dot title. So of course, if you have written the proper names of variable in your queries, so your evaluator, your teacher, your examiner, your customer, or your collaborators, team members would understand it easily, and even you yourself, when you will read your cipher again, you will understand it easily. Okay, so as in length, as a number of movies, length, of course, length of that collection of movies title show you that number of movies. So it should order first of all on the basis of number of movies, and then you can make it like as release year. Number of movies release year. So you can also make it release year. So now your query would give you more sense when you will read it. Okay, so there is a mistake. We have M capital here. Okay, now you can see the results are also giving you proper sense, proper semantics, and the query is also giving you much more sense. So your query should be like this. Okay, now I hope that you could understand the step-by-step guide, step-by-step evolution, step-by-step construction of Cypher queries to extract some simple or complex information or facts out of the knowledge graph. Hope you could understand. And if you still have any problem, we can discuss that in our interactive sessions. Okay, so your task is to find out the most famous, the most experienced actor, and the most experienced director. And I would recommend you that when you will find out the most experienced actor out of this graph, do Google as well that who is the most experienced actor, and then match your results. As this is the data I am claiming, and Neo4j is claiming that this data of the graph database is from the IMDb. So if Google is also using the IMDb data, so it should tell you the same results that this graph should tell you. So that is the criteria that you can easily see that your results are correct or not. If your query gives you the name of person that is also given you by the Google search, so it means that your query is correct and your results are correct. Okay, so let's see where is a further resource there where you can learn Cypher queries. Just Google it, Cypher commands. Let's see if recording is continue or not. Hopefully. Okay, so here on the first page, I have opened the first link, and on the first page it's a basic concept about a Cypher query language, and then what is a graph, and there's a basic video as well on the next page. So these are the basic concepts we have discussed in the previous lecture. And when you will click here, Cypher basic 1 also gives you extremely basic concept of Cypher. We have already covered that in previous lecture. It is also showing you a video. If you have skipped those concepts, you should also see this video as well, and go through this tutorial, and this would give you the basic idea about what is node variables, node labels, um, basic schema of the graph, and then basic instructions like create, match, and so on. And they are giving you a lot more examples, and for each example there is a cipher as well, and graph output as well. So you should follow this tutorial for making your practice much more stronger. So when you will click on this Cypher basics 2, you will see here we have the um, most frequent keywords that are utilized to construct your query. Basically CRUD operations, create, update, retrieve, delete operations. These are basically keyword create. You have already seen them, most of them, but some of them you will see here are very important. Like first of all, there comes a set keyword. Set keyword is used to update any attribute uh, while in during the query execution on the runtime, basically. And then there is delete keyword, very important. It's used to delete a single node that does not have any relationship with other nodes. but and this just to delete a single relationship between two nodes. But if you want to delete a node that have the relationships with other node, uh, then if you might have um, remember that there was a concept in a relational database, that is referential integrity. If a node have relationships with other nodes, so you must remove, you must delete those relationships before deleting that node. I'm repeating again, if you want to delete a node and it has relationship with other nodes, first of all you need to remove its relationship with other nodes, then delete that node. So for that purpose we have very useful command, that is detach delete. So detach, if you use this command detach delete, it it just not delete that node, it also delete all of the relationships associated with that node. So and to remove properties, you delete properties, you use remove keyword. And then yes, we have very important keyword, it's very useful, that is merge. So merge act like both match and create as well. So here in a few next examples we have it's very clear understanding. Here we have, so if you are using merge in place of match or create, it would work as both. First of all, it would search about this node in the graph database. If it finds, then of course it work as match and it load the information of that node into this variable. But if that node, it does not find that node, it would create that node and place its data into this variable. And further you can also use on keyword along with the merge, like you can further explain it that okay, if it creates a node, like if it does not find any node and if it creates that node, then set this property, like starting date, and if the node already exists, mean on match action, it should update that attribute. So it's a very useful keyword that works as both match and create. So that's it. These are the links. If you want to further dig down, further dig into these concepts, you can click on them and go further. And when you go through all of these, you should move on to the next, like filtering query results. This becomes a very important if you want to work further in these queries, like filtration of results, like optimization of the query. You should use this, you should go through this. And then there comes the sub queries, like when you have a little bit complex queries and you want to hold intermediate results, and then you want to perform analysis on that results to get the final results, you should follow this tutorial. And then there comes aggregation, return, and functions is also important. So up till here, this at least 5 or 6 tutorials or pages are very important for you. You should go through them. In aggregation, of course, you actually combine the results from different types of graphs and then generate the final results. And in returns and functions, it's also very useful. Like you can utilize any your Java code, Java function into the Neo4j by importing it as a plugin into Neo4j. So it's all about that. So must go through these tutorials at least up till here, aggregation, return, and function. So hopefully you will learn a lot from it. And for any further query, you can contact me, or we will discuss in interactive sessions. Thank you so much. That's all for now.